In this video, we're going to learn how to determine the molar mass of a substance based on its colligative properties, and we're going to do this by solving this problem. So this says a 26.4 gram sample of an unknown compound is dissolved in 75 grams of water. The resulting solution has a freezing point of negative 5.10 degrees Celsius. What is the molar mass of the unknown substance? So the freezing constant of water is 1.86 degrees Celsius per molar. So we're dealing with the colligative properties, and we're dealing with freezing point depression. So I'm going to start with the equation for freezing point depression, which is the change in freezing point, or delta T sub F, is going to be equal to the freezing constant times the molality of the solution. Remember that molality, this stands for the moles of solute per kilogram of solvent. And so in this case, the solvent is water, and then the moles is referring to our unknown compound. So I can look at what I'm given, what sort of information I'm given in this problem. And I'm given the mass of the substance that is dissolved. I'm given the mass of the water, given the freezing point of the solution, and I'm given the freezing constant. So what I'm going to do is I'm going to rearrange this equation right here, and I'm going to solve for the molality. The reason I'm going to solve for the molality because I know the freezing constant and I know the change in the freezing point. If I get the molality, remember that that's moles per kilogram, I can multiply the molality by the kilograms of water. I can convert this into kilograms by dividing by 1,000, and I'll end up with the moles of the unknown substance. The reason I want the moles of the unknown substance is because molar mass is in units of grams per mole. And so since I already know the grams, once I have the moles, I can take the grams and divide it by the moles. So let's go ahead and rearrange this equation. So I want to solve for molality. And to solve for molality, I'm going to divide both sides by this constant here. And I'll end up with molality is equal to the change in freezing point divided by the freezing constant for water. And now I can go ahead and plug in those known values. So the change in freezing point here is 5.1 degrees Celsius. So it changed from 0 degrees Celsius, which is the normal boiling point of water, and it went down by 5.10. We don't need the negative sign because we want the change, not the actual. So that's how much it changed by. And then we'll divide by the freezing constant, and we'll plug this into the calculator, and we'll end up with a molality of 2.74 molal. Now the molal symbol really stands for moles per kilogram of solvent. So I want to solve for the moles of solute. So I'm going to rewrite the unit here like this. I'm going to expand it. So this lowercase m means moles per kilogram. And what I'm going to do now is I'm going to multiply by the kilograms of water. So 75 grams divided by 1,000. We want to convert that into kilograms. And I can plug this into my calculator and take 2.74 times 0.075, and I end up with 0.206 moles of solute. So now I can solve for the molar mass using this equation right here. Remember, molar mass means grams per mole. Now I have the moles, and I know how many grams of that substance I started with. So 26.4 grams. And we'll divide that by the moles of 0.206 moles. We'll plug that into our calculator, and we end up with 128 grams per mole for the molar mass of the substance.